Alright, this video is about solving quadratic equations by the quadratic formula, and the sequence that this goes in for the book that I'm teaching from. This is kind of middle to late part of this chapter, so it would be nice if you already knew how to square root things and simplify square roots, and maybe some more information similar to that. Otherwise, we don't need a whole lot before we go into a lesson like this, other than just general math knowledge. So before this, we've talked about how to solve quadratic equations using square roots, and in the video or lesson where we talked about how to solve by graphing, we pointed out that there's a reason that makes solving by square roots only applicable sometimes if it does, and it's that it doesn't have the x term where there's just an x and not an x squared. That's the only time that we can use square roots to solve. Graphing has its limitations because if our answer is not an integer, then it's really hard to tell what it is if we're graphing. And so this is our first method, or actually the only method that, there's another method I guess that works all the time, but this is our most consistent method, is using the quadratic formula. And so that's what this blank up here is. Given an equation in standard form, ax squared plus bx plus c equals 0, you can use the following formula, which we call the quadratic formula, to solve for x. And so basically what you have to do, and what everyone who takes Algebra 1 and Algebra 2 has to do, is you memorize this formula so that you can use it. This formula has a, b's, and c's, and so we use the numbers in front of x squared in front of x, and then our number that doesn't have a variable, to fill into this formula and then simplify. And we do that in a pretty specific way to where we should be able to get in the habit of doing the same kind of thing over and over again. So one of the toughest parts of this will just be memorizing that formula, and other than that, it's just practice, because these problems can be a little bit on the long side. So the steps are that, for one thing, we need to make sure the equation has everything on one side so that it's standard form, so that we can pick out on number 2 what a, b, and c are. And once we know what a, b, and c are, we plug the numbers into the formula. Once they're in the formula, we're going to do kind of 3 things, and I guess I kind of skipped part of that in my explanation here. We want to simplify under the radical. We also want to multiply on bottom the 2 times a. We want to simplify under the radical, though, and simplify our square root. We don't want to get out our calculator and take the square root. We want to be able to simplify it like we did earlier in the chapter. And then, if possible, like if we get rid of the square root, we'll separate it into 2 expressions and figure out what the numbers actually are. Sometimes, though, we'll be stuck with square roots and we won't be able to keep going. And there are some examples that work out each of these ways. A trick to remembering the quadratic formula is that you can pretty easily put the quadratic formula to the tune "Pop Goes the Weasel" using the words in this way that I have written, and trying to decide if I want to sing this for potentially all of YouTube. I mean, it really could make my YouTube career just completely go off the charts. I don't know. So I guess I'll go for it. So it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's the tune of "Pop Goes the Weasel" with the quadratic formula in it. And I'll be honest that even though I didn't learn the quadratic formula this way originally, I think of it every time I need to write down the quadratic formula or solve a problem. So it is pretty helpful. Now, we need to remember as we're solving these that there is a certain order of operations. We have the acronym PEMDAS, which we use to remember what order we go in. And what's important here is this parentheses and other grouping symbols means that the radical in some ways is like us having, or in every way, is like us having parentheses around what's inside. So one of the first things we do before we do other stuff is we figure out what is the b squared minus 4ac part. so that we just have a single number underneath our square root. That comes before us trying to simplify things outside our square root with things inside our square root. And actually, we don't do that anyway. We wouldn't simplify what's outside with what's inside because that's not how it works. So, but one of our top priorities will be, what is the number that's underneath the radical? And we're not allowed to square root what's under the radical until we've actually figured out what it is as a number. So let's do an example. I have a template here of the quadratic formula because I think it makes it easier to see how this works. This is already in standard form. And if I rewrite this, I've got a 4 in front of x squared, a negative 5 in front of b, and a negative 9 for c. And so everywhere that b is, I'm going to put negative 5. So here goes negative 5, and here goes negative 5. And since it's a negative, I should really put these in parentheses to help me plug them in correctly. Here where I have a, I'll put 4. Down here where I have a, I put 4. And then where I have c here, I'll put negative 9. And so what I want to do is simplify this as much as possible. Ideally, I can end up with just 2 numbers as my answer, but sometimes we don't, and we'll see that happen on the next example. So here's the things we can do. We can say, what is negative 5, which is a positive 5. The plus or minus symbol is just to say that we're going to get 2 answers to this, just like we do for almost every quadratic equation we solve. And so right now we're leaving it as a plus or minus, and later on in the problem we can actually separate into 2 different things, one with a plus and one with a minus. So underneath our square root, we're going to do negative 5 squared, which is negative 5 times negative 5, which is positive 25. And then we're going to do negative 4 times negative 9. Well, there's 2 negatives there, so that makes it a positive. And we're going to do 4 times 4, which is 16, and then multiply it by 9, which may require you going off to the side and multiplying that out, which is totally fine. And then on bottom here, we've got 2 times 4, which is 8. There's one other thing that we can do before, or that we need to do before we square root this. We need to do 25 plus 144, which gives us 169. So we'll make that change. And it may be that we could have gotten straight to 169 from the b squared minus 4ac, and that's fine. But what we need to know now is, can I square root 169 and get an answer? Now this is tough because that's not actually a part of our multiplication tables. So when we have numbers that are this big, it can actually be kind of frustrating to have to try to come up with, well, what could this be as a square root? If we know that 12 squared is 144, then the most logical thing would be to multiply 13 times 13 to see if that works, which you get 9 and 3 and then 3 and 1, and oh look, it is 169. So this might be a situation where it's actually helpful to try to memorize a few more squares up past 12. Once I take the square root of 169 and get 13, there's no longer a square root. So the very last thing we do is we say, okay, this is a plus and minus sign, which means there are 2 things happening. One is that I have 5 plus 13 over 8, and the other is that I have 5 minus 13 over 8. That's literally what a plus or minus sign means, is that this is really talking about 2 different expressions, one that has a plus and one that has a minus. So we would actually work this out. 5 plus 13 is 18 over 8, which simplifies to be 9 over 4. This is one of our answers for x, and then we do the same thing with the second expression. 5 minus 13 is negative 8 over 8 is negative 1. So our 2 answers here are 9/4 and negative 1. That is what x equals. So that is a whole problem. It's kind of a lot. Some of them are shorter than this or easier than this because of the numbers that we just happen to get. Some of them might be more complicated than this, but this is how this works. And if that seems super overwhelming to you, just know that the most important thing to do is practice, and it'll get easier as you practice. All right, so I have on each slide the quadratic formula up at the top right. We would want to work on having that memorized, but as long as we're practicing, then we want to make sure we know what the correct quadratic formula is. So the first step is to check to see if it's in standard form, which means everything is on the same side, which it is. We're going to figure out what a, b, and c are, which a is in front of x squared, b is in front of x, and c is the number. And also keep in mind that we don't put the x's or the x squareds with a and b. A and b are the numbers in front of our variables. Now let's fill in our quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So basically, just as you read out the quadratic formula to yourself, anytime you get to a letter, put in what number goes with that letter. Negatives especially need to go in parentheses, although you can put both negatives and positives in parentheses, which is what I ended up doing here. So we need to say negative negative 2 is positive 2. We're trying to figure out under the radical what 4, because that's negative 2 squared, plus, because we've got a negative in front of 4 and a negative in front of 6, 4 times 2 times 6. So that's 8 times 6, which is 48. And on bottom we've got 4. So we add together 4 and 48 and get 52. And then we say, drats, 52 does not have its own square root, but I bet that we can simplify this square root by thinking of any perfect square factors that might divide into 52. The best candidate is 4. So check and see if you can divide 4 into 52. It goes into 5 once with 1 left over. It goes into 12 3 times. So 52 divided by 4 is 13. So we split it up into something we can square root, which is 4, something we can't square root, which is 13. And so square root of 52 simplifies to be 2 square roots of 13. Now, here's something that's important that may or may not have come up to you before now. What the top of this is saying to do is do 2 plus 2 square roots of 13. That's not actually something that we can do unless we pull out our calculator. Our calculator can tell us what that is as a decimal, but we don't want that as mathematicians. We want to leave it with square roots and fractions. So you can't put these together. This is not 4 square roots of 13 or something like that. So when we get here and we can't get rid of the square root, essentially like we're done as far as like we don't have to separate this into 2 different things and try to find really nice answers because we already have a square root. What we can do is we can check out the numbers outside our square root. So the 2 in front, the 2 in front of the square root, and the 4. We can look at those 3 numbers and say, are all 3 of these numbers divisible by the same thing? And if they are, we can do that. So these are all divisible by 2. So we'll divide each of them by 2. Which means 2 divided by 2 is 1, not nothing, but 1. 2 divided by 2 is 1. And 4 divided by 2 is 2. We don't actually need the 1 in front of the square root of 13, but that is our answer. 1 plus and minus square root of 13 over 2. And that's kind of an uncomfortable answer, especially with where we're at in math, that we haven't gotten answers like that before that are quite so uncomfortable as that. But spoiler alert, we could potentially get those more and more often the farther we go in math. That it just isn't always a nice integer that we get at the end of a problem. So if we get a square root we can't actually square root, we try to simplify it. If we can't simplify it, we basically circle what we have because we're done. If we can simplify it, then we've got to check to see these 3 numbers, the one in front of the plus and minus, the one outside the square root, and the one on bottom, are those all divisible by the same thing? And if they are, we go ahead and divide by that number. I've got two more examples, and so these are not in standard form initially, so you have that first step to do that we haven't had to do, and then otherwise it's the same kind of problem. So this is the point where if you think you've got the hang of it, or even if you don't, it might be a good idea to pause the video and try to work it out on your own and see how far you can get, and then turn the video back on when you're ready to see how you did. So first off, putting it in standard form means that we want everything on the same side and in a certain order. So I would add 7r over. Remember, you can't just move it. You have to add it if it's negative or subtract it if it's positive. But we want r squared to be first, and then r, and then our number, so that we know that a is 4, because it's what's in front of the squared term, b is 7, it's what's in front of r, and c is negative 11. When we're going to plug this in to our equation, we get negative 7 plus and minus square root of 7 squared minus 4a, which is 4, c, which is negative 11, and then on top of that is 2a, so 2 times 4. So I don't have two negatives here, so this stays negative 7. 7 squared is 49. I have a negative here and a negative here, which makes a positive, and we need to do 16 times 11. Which is 176. And 2 times 4 on the bottom is 8. We need to add 49 and 176 together, which gives us 225. The square root of 225, again, that's kind of a big number. That's bigger than 144, which is as high as we had to learn back in the day with multiplication tables. So we could think about, because we did 13 squared earlier, we could think about 14 squared. And really all we have to do is get to the part where we get a 6 here and we know that it's not right. So then we could try 15, and it at least has the right first number, so we can see it through. And yes, 15 squared is 225. So the square roots evenly. So we replace square root of 225 with 15. And then we look at this and say, now that I don't have a square root, I can make this into two different things. I can make this be negative 7 plus 15 over 8, and I can make this be negative 7 minus 15 over 8. So the top one, we get 8 over 8, which is 1. And on the bottom one, we get negative 22 over 8, which is negative 11 fourths. And finally, again, we have to put in standard form first and then solve the quadratic formula. And so if you have not yet tried to do one of these on your own to see how you're doing, I recommend you pause the video, try it yourself, and then restart the video when you're ready. So I add 2p squared over and put this in the correct standard form. And I say a is 2, b is negative 2, c is negative 13, and then I plug into my quadratic formula. So everything's in my formula. I need to do negative negative 2, which is positive 2. I need to do 4, plus 8 times 13, which is 104. 2 times 2, which is 4. So we get 2 plus or minus the square root of 108 over 4. So right now, where this is, I can't do 2 and 4 and simplify that to be 1 and 2. I cannot do that unless I end up with a number in front of my square root that is also divisible by the same thing. And it has to do with the way simplifying fractions work. But you need to know that that's not how that works. It has to be everything outside of the square root. Everything has to simplify. And right now what's in front of the square root is a 1. And 1 is not divisible by 2, like 2 and 4 are. So we want to think about 108. 108 is 12 times 9. So that would give us 3 square roots of 12. But 12 can also be split up into 4 and 3. So that's 3 times 2 square roots of 3, so 6 square roots of 3. So the square root of 108 is 6 square roots of 3. So we make that change. So we don't have to separate this into two different expressions. We can if we want to, or if we were finding the decimal on our calculator, we would need to, because there's not a plus and minus sign on our calculators. But what we do need to do is look at the 2, the 6, and the 4 and say, can I divide all of those by the same number? Which I can. And that gives me 1 plus and minus 3 square roots of 3 over 2. And that's our answer. So that is solving using the quadratic formula. The problems are a little bit longer than most of us would probably like. There's plenty of places to mess up, so it's really important that we show our work every step of the way so our teacher can give us as much partial credit as possible. And then it's important for us to remember our rules for simplifying square root, or this rule where all three of our numbers have to be divisible in order for us to simplify. So there's a lot to remember. Practicing where you can actually tell if you got the right answer or not is going to be the best way to make sure you get this. So the quadratic formula.